So this question, we've got to find the values of k in the line y equals kx plus k minus 6 is a tangent to the curve. So there's going to be a whole bunch of things going on in here. We've got simultaneous equations, we've got quadratics, we've got discriminant stuff happening. So let's just take this one step at a time and say, okay, well, it's tangent to the curve. Let's see where the two things would meet and see what that tells. I'm going to do that by solving them simultaneously. They're both equal to y, so we can say that the kx plus k minus 6 is equal to x squared plus x plus 3. So that's the kind of simultaneous equations bit of it. What we've got now is a quadratic equation, so let's do the basics with that, which is setting it equal to 0. So we've got x squared plus x minus kx plus 3 minus k plus 6. And a bit of tidying, so we've got x squared, nothing much we can do with that, but here we've got our x coefficients, so I can do some factorising there. I'm going to write that as 1 minus k lots of x, so just check you're happy with how I've taken x outside the bracket there. And then this bit here is the constant term. I know that k is in there, but it's just a number, so we've got 9 minus k. So what we've got now is our quadratic, and we need to determine values of x such that the line is a tangent to the curve. And if that's going to happen, then we know for this quadratic, we know that b squared minus 4ac, the discriminant, has got to be equal to 0. So let's have a look at what our discriminant is. So there's a, it's going to be 1. There's our b, which is going to be 1 minus k. And there's c, which is going to be 9 minus k. So for the b squared minus 4ac, we've got 1 minus k all squared minus 4 times by a times by c, and we know that has to be equal to 0. Right, so multiply out the brackets, so I've got 1 minus 2k plus k squared, so that's that bit. Now we've got minus 4 times 9, so that's going to be minus 36, and then we've got the minus 4 times by the minus k, so that's going to become plus 4k equal to 0. Tidy that thing up, and we've got k squared plus the minus 2k plus 4k, so that's plus 2k minus 35 equals 0. Now what we've done there is we started out with equations in terms of x, where x is our variable, and we've now ended up with a quadratic, that k squared plus 2k minus 35, where k is the variable, and that's the thing we've got to solve because we know k is just constant values. So let's just now solve this one and see what happens. So I'm going to have a go at factorising it. It's fairly straightforward, so that's going to be 7 and 5 plus 7 minus 5, so that leads to k equals minus 7 and k equals 5, and those are the two values of k that will mean that the straight line is a tangent to the curve. Remember, our curve was y equals x squared plus x plus 3, and our line was y equals, and we had kx plus k minus 6. So if we had k equals minus 7, that would give us y equals minus 7x minus 13. And if k was 5, that would give us y equals 5x minus 1. Now, if we were to draw these things on a graph, it would look like this. Now, in the question, there's nothing that required us to put the value of k back in to get the actual equations of the lines or to plot them at all. I've just included them so you can get a sense of what's going on with the question, because it gets a bit confusing with the x's and k's and everything else. And just so you can see that, let's say, the lines have ended up as tangents to the curve.